Welcome. Today we're going to be looking at solving systems of linear equations. As always, we're going to be going through 5 questions and explaining them and looking at the intricacies of this topic so that you can ace the SAT math portion. If you like these videos or find them informative, please be sure to like and subscribe. And with that, let's get started. Question number 1. 5.2s plus 0.1r equals 0, and 0.7 times r plus 0.2 plus 3.2 equals negative 3s. If Rs is the solution to the systems of equations above, what is the value of s minus r? All right, let's see how we're going to approach this question. So we can expand out the second equation to make 0.7r plus 0.14 plus 3.2 equals negative 3. And then this, we can combine these two to make 3.34. And then we can look at the first equation and we can multiply that whole thing by negative 7. Sorry. So if we multiply this top equation by negative 7, then that makes negative 36.4. This is text that act question. So you can just do 5.2 times negative 7. Negative 36.4 minus 0.7r, which equals 0. And then we're going to add this up. And then this cancels out with this. And we are just left with negative 36.4s plus 3.34 equals negative 3s. Then we can add the 36.4s to both sides, and we get 33.4s equals 3.34, so s equals 0.1. All right. Then we can plug that back into here, and we get that 0.52 plus 0.1r equals 0. So that means that r is going to be negative 5.2. Negative 5.2. Then when we add up r and s, it's s. Be sure to know what your questions ask for. Usually it would be r plus s, that's why I thought of that. But here it is s minus r, which is going to be 5.3, and that is our answer. 5.3. All right, let's move on to the next question. And here it is. 3 times 4 minus a, all minus b, equals 5 times 3a minus 2b plus 8. All right. Seems like a complicated question, but let's expand out and see what we can do. 12 minus a minus b equals 15a minus 10b plus 8. On the other hand, the other equation, we get 6b minus 9 equals 7a. All right. Now, what can we do? Well, on this equation right here, we can add an a, we can add a b, and we can subtract an 8. And then we get 16a minus 9b equals 4. All right. And then on this one, we have 6b minus 9 equals 7a for our second equation. And then what do we do? Well, we try to eliminate one of the variables. We can use elimination here. Seems to be a lot prettier than substitution right now. So we're going to multiply this equation by 2 and this one by 3. And we add that up, and what do we get? We get 32a minus 18b equals 8, and 12 or 18 b minus 27 equals 21a. So this is going to cancel with this, and then we're going to get 32 is going for 8 plus 21a, and then we can add the 27 to both sides. We can subtract the 21a from both sides, and we get that 11a equals 35. So a is 35 over 11, which seems to be more complicated than it needs to be. But then we can plug that into one of the equations. We can pick the second one right here, get the calculator out, and then let's convert that to a fraction, and it becomes that b is going to equal to 172 over 33. So to add that to a, they're asking us for a times b. So 35 over 11 times this. That's going to be 6,020 over 363, which is conspicuously absent from the answer choices, which means that we needed to think again about what we're doing right here. Let's redo it. Right, this will happen frequently to you. You go on one path and then you realize that doesn't work, and you've just been doing not really like anything for the whole time, and we have to figure out why. And if you have seen it, then you can see why it happened, because when we distributed these two, we put just minus a minus b instead of minus 3a. Right, so let that be a lesson. Right. Now, thankfully, even though these problems are extremely long and sometimes mostly tedious, they aren't too bad, right? And because there's only one of these problems on the SAT usually, right? Then we can simplify this. We get let's do a different color. We get 18a minus the 9b equals 4. Right. So we do that, and then we move on to the second equation, which is going to be 6 minus 9 and then we do the same thing. We do the elimination strategy, and we end up with 36a minus 18b equals 8. I'm not putting the minus 18b because we know it's going to cancel out. Right, so we can just get rid of this part, multiply this by 2, multiply this by 3, and then we get that negative 27. Same thing, and we get 15a equals 35. So a 7 over a equals 7, and then we plug that into our equations. And it's going to be 38 over 9, and then we can do a times b, and it's going to be, what is it going to be? 266 over 27, which is that one right there. So here just shows you, be sure to check every step of what you're doing. Be sure that you know what you are doing, and be careful when you're doing these questions. And let's move on. All right, question number 3. 1.5a minus 4.5b. 0.5a minus 4.5b. And then we can expand the other side and get 3a plus 3b. Bottom is going to be 5.5b equals 5.5b minus 5a plus 2.5a, which is decently chaotic. So let's see what we can do about this. We can add the 4.5b to both sides on this equation, and we get that like 5 equals what? Then we subtract 3a and we get negative 1.5a, which means that a equals negative 5b. And then what? Then we look at the second equation, we subtract the 5b out from both sides. We get 0.5b equals negative 2.5a, and which means that when we divide that out, we get that b equals negative 5m. And how does that make any sense, you ask? We plug in b, we get a equals 25a, which means that 0 equals 24a, so a is 0 and b is 0. Now, if a is 0 and b is 0, does that work? Let's see. Right, so a is 0, b is 0. This becomes 0, 0, 0, 0, 0, everything 0. So b minus a is going to be 0. Right? And that is our answer right here. Right, of course, since you see that there are no constants, that should probably give you a tip off that there's going to be something related to zeros. There's just nothing else. There's no constants to offset that. All right, next question. 3s plus 2t minus 3 equals c, and minus 7s minus 5t equals 4. All right. So now what do we see? Consider the systems of equations above where c is a constant. For which value of c is there exactly one st solution where s equals negative 1? So let's plug in s equals negative 1 and we get negative 3 plus 2t minus 3. And that makes equals c. So 2t minus 6 equals c. All right. The other side, we get that 7 minus 5t equals 4. So that means that the 5t is going to equal 3. All right. Well, if 5t equals 3, then we can, well, then 3 equals 5t, right? So we can write this as 3 equals 5t. And then multiply this by 2 and add it up. And that way we eliminate this and we eliminate that. And we get that. Then we have to add on 10. So we get, and then we subtract this out and we get negative 8t equals c. Well, let's think about how we got here and what is actually going on. All right. So we have negative 8t equals c. And, well, whatever we pick for c, there's going to be exactly one value of t. So it seems like it should be anything, but that cannot be true because they're giving us 3 options and none of them are, and they can't all be correct, right? So let's restart and let's think more carefully about what the question is actually saying. So what the question is saying, so the systems of equations above where c is a constant. For what value of c is there exactly one s comma t solution where s equals negative 1? Okay. Now what does that mean? Now let's see what we can do. We can write that. What can we do? Let's try to isolate or cross out the, say, the t's this time, right? So we get 15s plus 10t minus 15 equals c. We're trying to eliminate, so multiply the first one by 5, the second one by 2, minus 14s minus 10t equals 8. Then this cancels with this cancels with this, and leaves just 1s. So then you have s minus 15 equals c plus 8. So we add the 15 to both sides, and we get s equals c plus 23. And since s is -1, then c would be -24. All right. So now we just figured out that c equals -24 when s is equal to -1. And that's not one of the int choices. So you might be tempted to just pick none of the above, but first we have to figure out why the other answers don't work. All right. So why did the other answers not work? Well, let's see. If we plug in c equals 4.8, right, and we plug in that s equals -1, what do we get? Well, let's find out. So let me get a different color. And we get that 2t minus 6 equals -4.8. So 2t equals 1.2 and t equals 0.6. Okay, now let's look at the second equation. Right, so we plug in the -1 as s and the t as 0.6, and we get 7 minus 3, which is equal to 4. So what happened here? What happened? Because this doesn't make sense, because this one also works, right? This one also works. We just found that if we put s equals -1, and then we just found a value of t for this. Now, what is going on, and why is this happening? Right, let's think about that. All right, so if setting c equals to -4.8, right, if that works, let's try the other ones, right? -4 4/7, which is just -32/7. Right, if you plug in that as c, then we're gonna add the 6, and then divide by 2, and we get that t is going to be 5/7. So we plug that in, times -5, and then the 7 minus that's going to be like 10. So that one doesn't work. Right, so that's the first one that we found that doesn't work, right? It seemed to us like all of them would work, right? But this one doesn't work. So let's try the next one, 18. Let's try 18. 18, we add the 6, we divide by the 2, we get t equals 12. Then we have 7 minus 60, and that's not 4. So this also doesn't work. This also does not work. So why did we get this? But why does this happen? There has to be some disconnect somewhere, right? And we need to find out what that disconnect is. So, well, we made it clear that both of these please do not work. That this one, these two simply do not work, right? And now, let's see what we can do. We're going to try to do the same elimination method and going to isolate C in terms of S, right? So we have we multiply the first one by 5, we get 10t minus 30, because s -1 equals 5c, and we get the multiply by 2 on the second one, and we get -14, or it would be just positive 14. It's like 14 minus 10t equals 4. All right. Actually, no, it does not equal 4. It multiplied by 2, so it equals 8. So then this cancels different color. This cancels with this, and then we add this and we get negative 16 equals 5c plus 8. And then we subtract 8 on both sides, we divide by 5 and we get c equals negative 8, which is exactly what is right here. So how did we mess up the first time? Well, the first time we messed up, it was because here we didn't use 5c right here, we just used c. Right, so that's why you have to be careful when you're looking at all of this to make sure that you're actually figuring out the right thing. And because of that, because of what we've seen, our answer is going to be A. And let's move on. All right, next question. Here it is. Wx plus 2y equals 3 times 1 plus y plus 1. 8 minus y equals 2 times 1 minus y plus 3x. In the systems of equations above, w is a constant. For what value of w, the systems of equations have exactly one solution, xy, with x equals 1. So here we can do the same thing that we did before, right? We know that w is the constant, and we just write our equation out. We get w, oops, not yet. W plus 2y equals 3 plus 3y plus 1. Right, so we can simplify this by subtracting the 2y from both sides, and we get w equals 4 plus y. Then on this second equation right here, now that's where we find out what y actually is. We get 8 minus y equals 2 minus 2y plus 3. 3x is 3. So then we add the y, or we add 2y to both sides, and we get that here that y equals 2 plus 3 is 5, minus 8 is negative 3. So the 4 plus the y is then going to be 4 plus negative 3, or 1. So it seems like y, or it seems like w should just be 1. Now, there's no reason to doubt this right now, but we should still check it to make sure. So if I plug in w equals 1, right? So let's clear all this. W equals 1. And let's think about this equation. So we get x plus 2y equals the 4 plus 3y. So basically, x equals the 4 plus y. X equals the 4 plus y. And on the second equation, we get 8 minus y equals 8 minus y equals the 2 minus 2y plus 3x. So we add the 2x, we subtract the 2, and we get 3, oops, we get 3x equals what? We add the y, so we get y plus 6. All right, so we have these two equations, and then we can subtract them from each other, obviously, and we get 2x equals 2, which means that the x equals 1, just as we were supposed to have it, which means that this right here is correct, and our answer is that y equals 1. And we are done with that set of problems. Be sure to tune next time when we look at our final topic in the heart of algebra. This video was on the systems of linear equations, and as you can see, there's not much to it. It's really just raw algebra using the skills of combining like terms, our skills of elimination and substitution in systems of equations. But that was it for this video, and I'll see you next time.